Welcome, friends. Transforming your laptop into a supercomputer. We have older generation laptops, 10 to 15 years old. How do we bring them back to life? How can we utilize them in different scenarios? This is our topic today. Think of your laptop as a terminal device. We can use it for a while longer by remotely managing very powerful devices. The goal here is not just to make use of the laptop. Connection scenarios to remote devices are also important. For example, it's not just about connecting via remote desktop software to manage visually. It's about sending commands securely via the command line and receiving feedback. Using our older generation devices powerfully in environments with weak internet, managing them efficiently, and managing them by connecting to remote servers. Now, what I mean might have sounded a bit abstract. Let me show you through the presentation. Our title is Transform Your Laptop into a Supercomputer. As you can see here in the presentation, there is one laptop. Whether it's remote server devices you've rented, or a desktop computer at home that you don't use or can't carry with you. We will look at what we can do with remote connection scenarios to it. We need to make some preparations to connect to our remote device. What are these? First, our modem at home is manageable. We have a Keenetic brand modem. We will define a VLAN for this. We will include our desktop device at home in this isolated VLAN network. Only that device will be there. When we access it remotely, we will only see our desktop or remote server device within the isolated VLAN network. This way, we will ensure the security of our home network. We will increase isolation by preventing devices with high security vulnerabilities at home from accessing this network. We will increase security. Well, we will try to increase it. After that, there is one more process we need to do to access this modem via SSH. After defining our VLAN network, we will set up an encrypted VPN protocol with SSTP VPN. We will enable our remote devices to communicate. As you can see on the left, here is an older generation laptop that you use while drinking your coffee at a cafe, on a mountain, in a field, or anywhere else. When you try to load some tasks onto this laptop, it will be sluggish. We can also manage our computer visually with remote desktop applications. However, the trouble here is that when our internet connection is slow, delays in images and glitches in the internet network can slow us down. So, how can we issue commands and receive feedback faster via the terminal? This is our goal here. Now, the scenarios for why we are doing something like this are available here. Here's the image of how we define a VLAN to our modem and how we enter this VLAN network via the SSTP VPN network. Here, we are piercing through the firewall directly. As I just mentioned, our isolation event is here. We defined a separate VLAN network. We placed our Windows device or whichever server device we want to access inside it. We separated our networks. So, other devices at home do not see the device we will access. This way, we only see the device we are connected to. We also prevent devices connecting remotely from accessing other devices at home. Think of this as permission control. First, we performed an SSH installation on the Windows 11 device. Our remote device at home had a Windows 11 operating system. We executed the SSH installation commands from here. We activated the SSH server. For traffic routing here, our remote device will be Linux Mint. It would have been a bit easier if it were Windows. Then comes the installation of the VSC remote feature. I will explain something quite different to you here. For example, let our remotely connected device be Linux Mint or Windows. I connected an Android phone to our device that connects to the remote server. We will run the code compiled on our remote device on our Android device via reverse tunneling. Afterward, we will access AI applications remotely. The scenario where we securely communicate with our local open-source AI models by accessing our VPN remotely from our computer. Here, we connected an Android test device with Android Studio installed to our laptop, either wired or wirelessly. We enabled the SSH server on our Windows 11 server. Our VLAN is active and isolated. We completed our SSTP VPN setup. We will connect to the isolated VLAN network by connecting to the SSTP VPN network from the laptop and then access our Windows device. We will run our Android codes here. These running codes will come back to our laptop and from there to our Android device. We will have conducted our trials this way over the tunnel, through the secure tunnel network. There is a disadvantage to SSTP VPN here. Your home network has 50 megabit download speed. Your upload speed is 15 megabit. When you connect remotely via SSTP VPN here, you will get a connection of roughly around 5 megabits. How can we increase our connection speed with different methods and infrastructures? We will talk about that too. We will also test that. Our priority right now is to ensure the connection of our devices over SSTP VPN. When we install the Termux app on our Android device, if we don't have a laptop with us, we will perform trials on how to wake up our server and remote device, activate our VLAN and SSTP VPN network, and then connect to this remote server using our Android device via Termux. We have this flexibility as well. Our slogan is, build your own bunker, reject hardware limits, become a ghost developer. Our trials will take place in this manner. Let's start our demo. Now, in our modem interface, under the Networks and Wi-Fi section, we have our home network and our guest network. I had already isolated the devices here. You press the plus button here and enter the new VLAN definition mode. Let me show you the already defined VLAN directly. I defined a VLAN network named INAV. I set the password the same for both 2.4 GHz and 5 GHz. Currently, only 2.4 GHz is active. There is the VLAN ID and such here. The device assigns this automatically. I enabled IP version 4. I do not recommend using IP version 6. It starts acting nonsensical there. In IPv4, I set the IP address block and the subnet mask. The DHCP server is active. It will distribute IPs automatically. Use modem NAT. You need to use this to enable internet access for devices on this network. You need to activate this. Once you define the VLAN, you install the SSTP VPN server from the system settings under Components. It becomes active after you restart your modem. You will define an SSTP user here, just one, so they can connect to the SSTP VPN. After defining the user, you enter the applications. You activate the SSTP VPN from here. The last thing we need to do before activating the SSTP VPN is to turn on the modem's built-in KeenDNS service. You enable cloud access. You will access the SSTP VPN using this domain name. Now I am enabling the SSTP VPN from here. The SSTP VPN is running. Is the domain active? Let's check that too. KeenDNS also needs to be enabled here. I have also enabled access over the internet here. Let's make sure our KeenDNS service is on. And let's make sure SSTP is on. The device is currently in remote access mode. I am moving our desktop device to the VLAN we created. We have moved our device. What do we need to do on the Linux side? Since we are on the same home network, I am currently connected to the same network, but it doesn't matter where we are connecting from here. You won't have much trouble with Windows to Windows VPN connections, but on the Linux side, you might run into issues. For example, when adding a VPN in network settings, there aren't many options that appear here. I brought up this screen by installing a different package. When you click Add here, a lot of options appear. You select the SSTP VPN connection from here. You click Create. We enter the domain name provided to us by the Keenetic modem earlier. We also enter the username and password here. When we click Connect to this VPN connection, our SSTP VPN connection is established. How will we know that the SSTP VPN connection has been established? Now, a logo should appear right here. For example, it says, VPN connected. Did you see it? We are now connected to the VPN. So, we are currently connected to the INAV network via IP, because it is directing us to that side. As you can see, we have established the SSH connection and I can now see the file system on the remote device. We can verify this, like this. We opened Visual Studio Code. We have a sample project called Test Application. You can see the status here. Now let's get to the Linux side. I opened VS Code on the Linux side. When you install the SSH extension, the rest is completed by the remaining extensions. Afterwards, let me open a new window from here. There is Connect to Host. You click on Connect to Host. Its IP appears. It comes up as Connect to this device. Let's connect to the test application. It is now connected. It connected because we entered the password previously. If we hadn't entered the password, it would have asked for the password in this section. You would enter the password there. I click Connect to Test Application. It asks to trust the folder again, and it's here. Did you see it? It is currently ready to compile on the remote device. So we are currently using the Visual Studio Code application on our remote device. We are not using any remote desktop application via SSH, directly via command lines. So, here in the project, when we change any source code, save it, and press compile, the compilation process will be completed quickly. Now we are connected like this on the Visual Studio Code side. Now let me show you something else. What is our situation on the Android Studio side? Do you see the device here? This device is the one appearing on our remote server. Where is this device actually located? It is on our Linux device here. Let's open a terminal right away. Let's type ADB devices. Since we disconnected the IP connection earlier, of course we will do it this way. We will say ADB connect. We will provide its IP. The device is now connected. Did you see it? Now, the device connected here, our port has changed again from here. Let's copy this. Let's open a new terminal. Let's change our port. We are connected now. We have connected our Android phone to our laptop in wireless debugging mode. Let's verify this immediately. Does Android Studio see our device from here? Let's see our Android device in the device list here. It sees it now. So, what did we do here? We started SSH. Our reverse tunneling port 5555, send the Android device with debugging enabled at this IP and port via reverse tunneling to this user on the computer at this IP address. Now that we've sent this, let's move over to this side. We see the device here. The device we see here is now the remote device. Did you see it? Now, where was our command line? Look, 127.0.0.15555. I said connect to the device coming to the server via SSH from the other device's 5555 port. I confirmed it. Look, now the part 1 connected from the table to show you the screen recording, and this is the device coming via remote reverse tunneling. Let's look at the display of our Android device. Let's open the screen capture. Now, look, I'm sending our test application to the device with this tunneling. It passed through the tunnel. It arrived at our Android device. Should we adjust the screen a bit like this? Now, here is the situation. On the Linux side, our device is connected. Let's open its VS Code as well, the test application. Look, it's asking for a password for this test application right now. Did you see? Because I closed and reopened VS Code. Now we are connected remotely to the application here. Let's look at build, gradle.kts. For example, when you add a change here. What happens when you click save? Let's open it again. Look, did you see? The change I made on the Linux device was reflected here. Now I deleted it from Linux and saved it. When I close and reopen this, did you see? The change came directly here. When I compile the application here, where is our Android device? It's coming here immediately, did you see? So, the code compiled on the remote server comes to the Android device via the Linux device here. In short, what I want to explain to you is this. When you make any change on the Linux side here, it is also reflected on the Windows side. The device is visible from here. When you send the compile command or the command to send it to the emulator from the Linux side, it will send the application to the device this way after the compilation process is finished. So, compiling code on remote devices via SSH and sending it to our Android device, or not necessarily an Android device, but compiling code and doing application projects on our remote devices will be easy this way. Meaning, our laptop does not need to be a powerful device. A simple laptop that connects to the internet, a notebook, or running VS Code or any development application is sufficient. It could even be a simple code editing application. You put the codes into the application, you send the compile command via SSH, the compilation process finishes on the remote device. After that, you retrieve the outputs. This way, you can perform your development operations from servers or powerful devices on your own home network via a secure connection with tunneling. That is the summary of the situation. In our next video, we will talk about the shortcomings and errors. We will communicate with AI models. If you like the video, don't forget to like and follow. See you in our later videos.